Okay, there is one more transformation that we can do with data, and that is called normalizing or standardizing the data. So if a variable has data distribution is not, you like the data to be distributed kind of evenly, like a normal distribution, like a bell-shaped distribution, that would be the best case. But not all variables will come with a nice bell-shaped distribution. Sometimes it will be skewed to the right or to the left. Okay, so in such a case, then you need to do some modifications. And another possibility is when you have several predictor variables and the scale of the predictor variables vary tremendously. For example, one variable, say a vehicle, a car, you're trying to predict gas mileage of a car. Okay, so now you have the automobile's weight. So the weight may be in the thousands, right? Like 2,000, 3,000 pounds in that range. And then you have, for example, the next variable is how many passengers that the vehicle can accommodate. So that's going to be like maybe 3 or 4 or 5 or 6. So on the one hand, you have variable that has values in the range of thousands, another variable that has values in the range of single digit. So in such a situation, some models it's not a big deal, but in some models, such a wide difference in the scale can skew the results. The variable with larger values will have a larger influence in how the records are predicted. So you don't want such scale disparity to affect your prediction. So again, that's also a case where you would normalize. So normalizing when the data is skewed, and normalizing when the data scale is widely different. And there are a couple of different ways in which you can do the normalizing. They all use the same logic, which is you want to put all the variables in the same scale generally. So normalizing function is, okay, that's the first case, normalizing or standardizing. These terminologies are interchangeable. It is like computing a z-score. So you take each value, subtract from the value the mean x bar, and then divide by the standard deviation. So x minus x bar divided by the standard deviation. So that's a z-score. So that would convert all the values into a range approximately from -3 to +3. All variables will have values in that range, so there is no scale disparity. So another way of doing that is to convert them into 0 to 1 range, and you do that by subtracting the minimum value. So you take each value, subtract from the value the minimum in that column for that variable. What is the minimum value? So, and divide by the range. Range is the range of values in the column. Range will be like you take the maximum value and subtract the minimum value from it. So that's your range. And SAS again allows you to do these modifications very, very easily.